welcome to LearnCity. My name is Praise and I'm your mathematics tutor. And in today's class, we'll be talking about trigonometric ratios, in which in our last class, we talked about trigonometry, explaining what trigonometry is, and explaining the 6 trigonometric functions, in which we have the sine, the cosine, the tangent, the cosecant, the secant, and the cotangent function. And today we'll be talking about trigonometric ratios. Now, what is trigonometric ratio? Trigonometric ratio is any function of an angle expressed as the ratio of two of the sides of the right angle triangle that has that angle, e.g. the sine, the cosine, and the tangent of an acute angle. In which trigonometric ratio, just as we said in our last class under trigonometric function, is just basically the same thing, where we are talking about the sine, the cosine, and the tangent of an acute angle of a right angle triangle. So peradventure, we have this right angle triangle, where we have this to be A, this is C, and this is B. So we have this to be A, this is our B, and this is our C. We have an angle to be this place, we have a right angle here, and we have an angle here. Now, to find our B and C, to find angle B and C, we use the sine, the cos, and the tan. We said so catua. Now, to find sine B, which is opposite over hypotenuse. Now, our opposite in this form is sine B is B, where our hypotenuse is A. So we have our sine B to be B over A. Then we have our cos B, which is adjacent over hypotenuse, in which we have it to be C over A. And we have our tan B to be opposite over adjacent, where we have it to be B over C. We have it to be B over C. And in this part, we also look for sine C, cos C, and tan C, as we have two angles in this triangle apart from the angle 90 degrees. So for sine C, we have it to be C over A, which is our opposite over hypotenuse. Now, in this right angle triangle, where the angle face will be opposite. So in this case turns to our opposite, here turns to our hypotenuse, and this is our adjacent. So we have our sine C to be C over A. Then we have our cos C to be B over A, which is the adjacent over hypotenuse. and we have our tan C to be C over B, where we have it to be opposite over adjacent. We have it to be opposite over adjacent. Now, it is important to know that in triangle ABCD, B and C are complementary angles, where we have angle B and angle C are complementary angles. As it is important to know that the complementary angles are sum of two angles are equal to 90 degrees, when we have B plus C to be 90, and we have it to be B degrees plus C degrees to be 90 degrees. Now, it is important to know that if B is 90 degrees, our C will then be 90 minus theta. So therefore, our sin theta will now be cos 90 minus theta, and in which reverse is the case, such as cos theta will be sin 90 minus theta. And today we'll solve some examples on this part to make it much more explainable and understandable. So we have these 4 examples today on trigonometric ratio, where we have our first example to be solve the equation cos 2x to be equals to sin 6x. We have cos 2x to be equals to sin 6x. Now, it is important to know that our cos theta is equals to sin 90 minus theta. So cos 2x will now be sin 90 minus 2x. So we have this to be sin 90 minus 2x to be equals to sin 6x. So you divide through by sin, and we have this to be 90 minus 2x to be equals to 6x. So we have 90 to be 6x plus 2x. We have 90 to be 8x. So we have our x to be 90 over 8. I have 2 here. It remains 90, which is 16, remains 4. Then we add 0, we have it to be 5. So our x is 11.25. That is 11.25 for cos 2x equals to sin 6x. Now, the next one is sin 2x, which is cos 6x. We have sin 2x to be equals to cos 6x, where we say our sin theta is cos 90 minus theta. So we have this to be sin 2x to be cos 90 minus 2x. So we have cos 90 minus 2x to be equals to cos 6x. So we have this to be divide through by cos. We have 90 minus 2x to be equals to 6x. Here we have 90 to be 6x plus 2x. We have 90 to be 8x. Where we have our x to be 11.25. So what this part is trying to tell us that even if the questions are reversed, the answers are the same. The answers are the same. And our next example will be cos 5x, which is equals to sin 10x. We have cos 5x, which is equals to sin 10x. So we have our cos theta to be sin 90 minus theta. So we have cos 5x to be sine 90 minus 5x. So you have this to be sine 90 minus 5x will now be equals to sine 10x. So when you divide through by sine, we have this to be 90 minus 5x to be equals to 10x. So we have 90 to be equals to 10x plus 5x. And we have 90 to be 15x. So we have our x to be 90 over 15. Where we have our x to be 4. That is 15 in 6 places. That would be 6. So our x is 6. So definitely if we solve for the other way around, we will also get 6. And this brings us to the end of our class on trigonometric ratio. Subscribe to our YouTube channel, like and comment, and we'll see you in the next class.